Hello students, today we're going to start with Lesson 12, Distributing Expressions on page 55. Please locate Lesson 12, Distributing Expressions. The very first two problems says create a model to show 2 times 5. So we want to show 2 groups of 5. There's 2 groups of 5. We're going to do the same thing, showing 2 groups of B, 2 times B. Two groups of B. Now we're going to write an expression that's equivalent to 2 groups of A plus B. So there are 2 ways you can think of it. 2 groups of A plus B. Or some students will look at it as I have 2 A's and 2 B's. Either way, you're showing equivalent expressions of 2 groups of A plus B. Go ahead and create a model showing just A plus B. The expression 2 groups of A plus B tells us that we have 2 of the A plus B's. Create a model showing 2 groups of A plus B. There I have 2 groups of A plus B. How many A's do we have and how many B's do we have? 2 of each. Moving on down, how would the model look if we group them together, the A's together and the B's together? I still have 2 A's and I still have 2 B's. I could now write this equivalent expression as 2A plus 2B. So what can we conclude? We can conclude that 2A plus 2B is equivalent to 2 groups of A plus B. So what if I knew that A was 3 and B was 4? We're going to substitute this in. So if I just kept these expressions up here and said, okay, I've got 2 times 3 plus 2 times 4. And I'll go ahead and solve that. 6 plus 8 is 14. Order of operations. But over here I have 2 groups of 3 plus 4. 2 times 7, which is also 14. So as I said, they're equivalent to each other. Please go on to page 56. This time, it says write an expression that is equivalent to double. That word double means 2, 3x, and 4y. You guessed it, we're going to rewrite this again, but this time we're going to write out 3x plus 4y plus 3x plus 4y. This is called the expanded form. We're going to start off like we did last time. We just have one group of 3x and 4y, and then we're going to show what happens when we double it. All right, are there terms that we can put together? Yes, we can put 3x plus 3x and 4y plus 4y. We could also put those even more together, 6x plus 4y. But because the variables are separate or different, we have to keep them separated. So what can we say about these being equivalent? We can say that 2 times 3x plus 2 times 4y is the same as saying 6x plus 4y. And you could even say that's the same as saying what we started with in the beginning. All right, we're going to skip the rest of that page. Let's go to the back side. Now we have 3 groups of 7D and 4E. So now we're going to have to show 3 groups of those. 3 groups of 7D plus 3 groups of 4E. That's equivalent to 3 times 7 is 21, the letter follows, plus 3 times 4 is 12, and the letter follows. Again, we cannot combine them because this is addition. In multiplication, we could combine them. In addition, we're not going to. All right, I'm going to show you one model, and I'm going to show you just mathematically with this next one. So 3 groups of x and y. Could be done that way, or you can alternate. Either way, I have 3 x's and 3 y's. Over here, I'm just going to show it mathematically. 4 times 2h is 8h. 4 times g is 4g. So these are equivalent to each other. Moving on down, we're going to go ahead and distribute in. You can think to yourself, 8 groups of h plus 3. That's the same as saying 8 h's plus 8 times 3 is 24. And the next one, we're distributing in 3 to the inside quantity. So 3 times 2h is 6h. And 3 times 7 is 21. Again, 5 groups of this quantity. Multiply it in. Four times 11 is 44h plus 12g. I'm not going to go into this model as much, but I do prefer the letter to be on the outside. So you can think of it just like we have over here. We have a number on the outside and then the groups. So we have 7k plus 12m with j. We like to keep those letters in alphabetical order if you can. Again, you won't see models like that on your checkpoints, so I wouldn't worry too much about it. All right, what happens if we have to distribute a letter in? So A times, that's hard to see, 9b, A times 9b. So that is the same as saying 9ab plus A times 13, so 13a. Again, we're keeping them separate because here we have A and B together, and here we just have A. But these would be equivalent to each other. Right, the problem set you will probably do in class with your teacher. Let's move on to lesson 13. Write an expression showing 1/2 without using a division symbol. 1/2. Well, let's see if this works. 1/2. Yep, that works. And if we were to draw a model, we're saying half of the whole. What if we want to do the same thing, but this time it just says a divided by 2? So again, a over 2. And you're showing that the model, all of this is a, and we're dividing it into two parts. When we write division expressions using the division symbol, we represent it with dividend divided by the divisor. And that equals your quotient. I'll just put equals the Q to remind you that quotient. And then we would have dividend as a fraction over your divisor. Again, equaling your quotient. So write an expression showing A divided by B without using the division symbol. So A divided by B. Write an expression for G divided by the quantity of H plus 3. Quantity, you could put parentheses around it, but you could also, in this case, just write G divided by H plus 3. And then the last one, write an expression for the quotient of the quantity, M reduced by 3. So we want to keep the quantity M minus 3 together. And then it says and 5. A lot of times students think and is plus, but because it said quotient, that will cue you in that that's the division sign and the 5 underneath. Now the quotient is the answer, but because we're taking this divided by this to get the quotient, that and is your cue to put it on the bottom as your divisor. Right, just a couple more examples on the next page. Exercises on lesson 13, 12 divided by 4. You can write it this way or like this. Preferably in algebra, we like the fraction. 3 divided by 5. A divided by 4. The quotient of 6 and M. There that is again. And M. 6 and M. 7 divided by the quantity of X plus Y. Again, if you wanted to put the parentheses, you definitely would want to do it if you wrote it this way. Again, in algebra, we will prefer the fraction. Y divided by the quantity of X minus 11. Again, parentheses are fine if you want to show that you're going to keep that quantity together. I'm not going to write it the other way, the horizontal way. The sum of quantity of H and 3 divided by 4. Now I talked to you about that word and, but this time it didn't say quotient, it said the quantity. So you're trying to keep the H and the 3 together. Again, parentheses would not necessarily need to be there, but it's a good idea to think of parentheses with quantity. The quotient of the quantity of K minus 10, so we want to keep that together, and M. So again, quotient and tells us that the rest goes underneath. Again, we will probably practice some in class, but just make sure that you took some good notes on the ones that we did do together. Have a great day.